Hello everyone. In this video I'm going to talk about events. Events are a special type of delegate which are used to create a broadcasting or notification system in your game. When your game is running, there are many actions that happen every frame, and some game agents may be interested in some of these events. So to pass information about a game action, and by game action I mean anything interesting that happens in your game, for example, your player dying or your game being paused, or if your player wants to restart the game. So these actions and information about these actions is transferred between your game agents using a notification or a broadcasting system which is created with the help of events. Now imagine a very simple game in which I have the following game agents. The first one is the player, and suppose these are the four enemies, and I have a simple tree. So the action which everyone is interested in is the player dying. So let's imagine that the enemies will show a particular animation when the player has died. So these enemies want to hear about that notification of player dying. And so the simple way to do this is that the player will, when the player dies, he will directly go to each and every enemy and pass him the information about the player, about the player's death. So in this method, the player will have a reference of all the enemies in the game, and when that particular event happens, that is of the player death, he will go and notify each and every enemy in the game. The few obvious problems are that when the number of enemies grows, or number of things that would want to hear about that notification, the interested parties of any game event, as this number increases, it is very hard for the player or the game object where the event happens, where the game action happens. It becomes very hard for that game object, the from where the game event originates, to have the reference of all the interested parties. Suppose you have a very huge game like Dota, or shoot them up kind of game where there are a huge number of game entities, then the number of references which the player has to hold increases by a huge amount. The second major problem is that you won't have all the enemies in the game from start. Some enemies may be as a prefab and they are instantiated during runtime. So when they are instantiated after the game has started, the player may not necessarily have the reference of those newly created enemies. The enemies may be spawned by a different game object. For example, let's say an enemy manager, and enemy manager is responsible for spawning the enemies. The player won't even know if that an enemy has spawned. So every spawned enemy must pass its reference to the player, and it again becomes a very cumbersome job. So a better method designed by software engineers is what we will discuss in this video. So this method of broadcasting information is similar to how a Facebook or Twitter works. So imagine a hypothetical scenario in which in real life you have died, and instead of informing all of these enemies by calling on their number that I have died, I have died, I have died, you just post that uh, information update on your Facebook page. So you just post it once that I have died, and all these enemies who are your Facebook friend, they will all be notified exactly at the same time without you even having to worry about whether those people got the notification, whether they know that I have died or not. This removes a lot of problems. The first one is that you don't have to remember, you don't have to have a reference of all these people that are interested about that event. You don't have to remember their phone number or their email address. Once you only have to post anything on the Facebook and they all will be notified. The second problem it solves is that you only have to post that information or that event once on your Facebook. Now, the number of interested parties or how many people are listening to that event doesn't really matter to you. You may have zero friends on your Facebook page, you may have 5,000, and you don't really have to worry about who are listening, and you don't have control over who are listening and who are not. So anybody who is interested in that event, it's their responsibility to subscribe to that event by becoming a Facebook friend or by other means, and it is their sole responsibility to get that notification by subscribing to your Facebook page. The third problem it solves is the dynamic nature of the listeners. So, if in our first solution, if a new enemy came who is interested in our death event, we need to get the reference of that new enemy. But in the new method of notification and broadcasting, if a new enemy comes and he is interested in listening to our death event, it's his responsibility to subscribe to that event by becoming a Facebook friend. And once he becomes the Facebook friend, he will get the event or notification of your death. So converting this simple example to a coding vocabulary is as following. So when any game action happens like player death and you post it on Facebook, in coding terms this is called firing an event. The player death is an event, and when that event happens it's called firing that event. And generally the place where the event originates, for example player death, generally happens in the player script, or some game related events like game pausing happens on the game manager script. So generally the place where the event originates, that is the place where the event is fired. Now these enemies who are interested in that event, so they become your Facebook friend or they become a listener to that event, and the process of becoming a listener to an event is called subscribing to that event. And suppose if an enemy dies, he is no longer interested in that event, he no longer needs a notification of that event. So unfriending from your Facebook, this in coding terms is called unsubscribing from that event. So there are two terms, subscribing and unsubscribing. Since events are just a special kind of delegate, I would request you to please check my video about delegates, whose link will be in the description below. So I have a very simple setup here. I have a player and I have an enemy, and I want my enemies to be notified of player's death. I will also create a prefab of this enemy, and I will show you how in runtime the enemies which are generated at runtime, they will also be notified of my player's death. Since generally we create the events in the script where the event originates, so we will come to our player script and start creating the player death event. So the first step in creating an event is to first create a delegate of that event. And as we have seen in the our delegate video, the delegate just defines a signature of the function. And in the case of events, this function defines the information that is going to be passed to the enemies. So to show you an example, public delegate, and after the delegate keyword we will define the signature of the function. Now the signature of the function solely depends upon what information that you want to pass around with that event. So in this case we will keep the thing simple and just pass an empty function, which is just a simple notification without any extra stuff. And later when you are creating more complex events, you also may want to create complex delegates which will also pass some parameters along with the notification. So here I have a simple delegate, let's call it player death delegate. It takes no parameters, and once we have created the delegate which defines the type of information that is going to be passed with our event, we create a event of the same type as the delegate just that we have just defined. So we will take player event delegate, and the name after our delegate type is will be the name of our event. So let's name it player death event. Now this completes the creation of our event. This is the event that the enemies or any party interested in this event will be subscribing to. Once we have an event, the next step is to add some listeners to this event. And the way to do that is coming to our enemy script. To add listener to the event, the first step is subscribing to that event, and the second important step is to always unsubscribe to that event in the case when the listener or the game object, suppose this enemy, is destroyed. So we always want to make sure that if we are subscribing to an event, we should make sure that we also have provision for unsubscribing for that event. And it is generally done in the void on enable function. This is the place where we generally subscribe to that event, and void on disable is the place where we generally unsubscribe from an event. The reason we use on enable to subscribe is because on enable is called before the start. So if an event is fired right in the start function, on subscribing in on enable ensures that we are subscribed to an event before it is actually fired. And unsubscribing is done in on disable because on disable is guaranteed to be called on a game object when it is destroyed. So if your enemy dies, your on disable will be called, and this will ensure that you always unsubscribe from an event if you have subscribed there. Now the actual process of subscribing or unsubscribing to an event in, involves first having a function which matches the signature of the delegate, that the event that we have. So for this event, player death event, the delegate is of the form void and taking no parameters. So we will create a function, and generally we create the function with the same name as the event and just add a prefix of listener to it. So we will name it public player death listener and taking zero parameters, and this will be the function that will be used to subscribe to that event. And the way we subscribe is that we either take the reference of the player so that we get a reference to this event, or we can just make this event as a static variable so that we can always subscribe to that event without having a reference of the player. So now when the event is static, we can just call player2 dot our event, and +2 operator is used to subscribe, and we have to write our function name here, player death listener. And similar to this is the minus equal to sign, which is this operator is used to unsubscribe to an event. This is subscription and this is unsubscribing from that event. I will add a small debug here so that we know that this function is being called, that we are notified. So let's write that. Now whenever this function is called, we can get a debug.log message, and the only thing left now is to fire the event. And since we don't have the full game running, we will just use a simple keyboard click to simulate player death, and on that player death actual action we will fire this event. So if input dot at this keyboard click, we want to fire that event. And the way to fire the event, there are two ways to fire an event. The first is simply writing that event name and our brackets, and the next way is to player death event dot invoke. So it is similar to how we called our delegates. We can use any of these methods, and whenever an event is fired, all the listeners that are subscribed to that event, that all those functions which are used to subscribe to this event, all those functions would be called. So coming to the game, and whenever we hit X, the player event will be fired, and now we just have a single listener. So this enemy we will get a debug.log message that this enemy has got that event. So here is our debug message how that player died, and every time that event is fired, the function inside the enemy which is used for subscribing, this function is called every time the event is fired in the player script. A very few quick tests that we can do is just duplicate the enemies 7 times, and now we can see that we don't have to tweak the player even once. The player doesn't have to know that is a single enemy or there are 8 enemies in the game. It fires the event exactly like it has done before. So we will just press X once, and all the 8 enemies that are in the scene, they all got the notification that the player has died. The code which is with the player code doesn't has to change depending on how many players are in the game. The player has no information, the player has no reference of any enemy in the game. It is the responsibility of the enemy to get that notification. So it solves the huge problem of always updating the reference of everything in the game. Now I will show you how this system responds to dynamic enemies or enemies that are instantiated during runtime. So let's delete these extra enemies and create a prefab of my enemy, and we will add that we'll spawn that enemy during runtime, and let's see if that enemy gets the notification of player death. So right now I have a single enemy and we get a single notification that this player heard the enemy died. Now I will add 2 extra enemies in the game, and now when we press X we can see we get 3 new messages. That means now 3 enemies are listening to player death, and if there is a logic that they have to do, for example playing a sound or a pop-up or an animation change, they all will respond accordingly even if they have spawned after the game started or etc. Now let's also see what happens if we destroy some enemies in runtime. So now we have 2 enemies left, and when we press X we see 2 messages based on how many enemies are left in the scene. So you can clearly see how flexible this broadcasting system is. To conclude this video, I will quickly show you how you can also pass parameters, arguments with these events. So coming to the player class, I have created a new delegate which now takes a string as an argument, and I have created a new event using that delegate. And when I press X, instead of calling my old event, I am calling the new event, and inside that event I am also passing a parameter or any string, which in this case is Hugo. And coming to my enemy script, I have created a new listener which also now takes a string as an argument, and I am debugging using that name. And instead of subscribing to that old event, now I am just subscribing to my new event. So there are simply just 3 differences: that I have to change my delegate whenever I am firing that event, I have to provide it an argument, and the listener now has to match the delegate type of that event. Now giving it a run inside Unity. Now when I press X, you will get the event. You can see the enemy also gets the argument that is passed from the player. You saw me how we made the event as a static variable so that every enemy has a reference to it. You can achieve the same thing by making the whole player 2 class as a singleton, and then they can have a reference to this event using that singleton variable. Now this was a brief introduction to events. They are very versatile and used in a lot of number of ways. In they are very well tested system used in variety of software, but in the case of Unity they are mainly used in 2 fields. The first is in the Unity GUI system, All the interaction between the Unity GUI controls and your code happens through events. And the other thrust area of their use is when you have a dynamic enemies or dynamic game entities, and you have a huge number of entities that are interested in a particular event or notification. In those cases, event system is preferred over having a direct reference and direct calling and direct notification system. Direct notification system and having reference is still better if you have a single entity firing an event and a single entity listening to that event. So for example, communication between game manager and the player can still happen with the direct reference method, but when you have a huge number of listeners, then the event broadcast system becomes superior to the direct reference system.